In this lesson, we're going to talk about solutions and solubility. Solutions are created when a solute is dissolved in a solvent because it is soluble. So what is a solution? Well, we learned about this back in the nature of matter unit. We talked about how a solution is made up of two components. Okay. The two components are our solute, which is our smaller quantity, and our solvent, which is our larger quantity. And we know that a solution is what we call homogeneous mixture. And if our solvent is water, for example, then we call these another type of solution. We call them an aqueous solution. And if we talk about soluble, what soluble means is soluble means it can dissolve. The opposite is called insoluble. And why is that important? It's because this allows us to modify concentration to what we need. Now, what does solubility really mean? Solubility is defined as the amount of one substance that will dissolve in a certain amount of another substance at a specific temperature. Okay, and this is measured in grams per liter or grams per 100 milliliters. And this, because it depends on temperature, it's based on kmt, because as a particle heats up, it will move faster and thus it will dissolve faster. Now, what type of solids can dissolve in solution? Well, we know ionic salts can. Most of them. Because when they dissolve, they dissociate into charged particles. We also know certain polar covalent compounds can dissolve in what we call polar covalent. But there's also nonpolar. Nonpolar covalent can dissolve in nonpolar covalent. But there's one more. Ionic can actually dissolve in polar covalent. So this is why ionic, such as for example salt, can dissolve in water. Now, what does the term saturated, unsaturated mean? We talk about saturated. Saturated means no more solid can dissolve. And we talk about unsaturated, it means more solid can dissolve in solution. Now, we talked about dilution previously. We know that dilution is where we are going to be lowering the concentration of something, right? as measured by C1V1 is equal to C2V2. So in this case, we know that this equation allows us to calculate dilution of anything. So let's look at an example. A student has a 500 milliliter sample of 0.400 molarity NaCl solution. How much water is needed to make the solution to become 0.100 molarity? Well, in this case, this is your V1, this is your C1, and this is your C2. So C1V1 is equal to C2V2. So in this case, what we have here is that we see that what we're going to have is C1 is 0.4 molarity, V1 is 500 milliliters, is equal to 0.1 molarity times V2. To solve, we just divide both sides by 0.1. And what we're going to get is we're going to get V2 is equal to, if we punch our calculator, 0.4 times 500 divided by 0.1, we're going to get 2,000 milliliters. To the correct number of sig figs, this will be 2.00 times 10 to the 3 milliliters. We're going to need that much water total. Example number 2, a chemist adds water to 120 milliliters of 6 molarity solution of NaOH until the final volume is 2 liters. What is the final concentration? Well, in this case, again, C1V1 is equal to C2V2. If this is V1 and this is C1 and this is V2, we're trying to solve for C2. So we have 6 molarity times 120 is equal to C2 times 2,000 milliliters. Divide both sides by 2,000 milliliters, and you're going to get C2 is equal to, in this case, 6 times 120 divided by 2,000. This will be 0.360 molarity. You look at example 3 now. We see that in this case, what concentration will result when 150 milliliters of 0.36 molarity magnesium sulfate is added to 900 milliliters of water. So here we have our V1. This is our C1. This 700 milliliters is not our C2 though, because we're adding 750 milliliters to this 150. So in this case, our C2 is actually 150 plus 750. That's actually 900. So again, C1V1 is equal to C2V2. Our C1 is 0.36. Our V1 is 150. Our C2 is unknown, but our V2 is 900. So divide both sides by 900. Put that in your calculator. So 0.36 times 150 divided by 900. Here you got 0.06. So your C2 is 0.0600 molarity. 3 sig figs. Our last example here is where you have a double dilution because you have mixing of 2 different types of chemicals together. In this case, the same type of chemical. So your big thing is knowing what C2 is. In this case, C2 is going to be 600 plus 900. That's 1,500 milliliters. So again, C1V1 is equal to C2V2. You gotta dilute both of them individually and then add their final concentration together. So what you're going to have is 0.5 times 600 for the first one is equal to C2 times 1500 is the first one. Your second one is going to be 0.75 times 900 is equal to C2 times 1500. So you divide both sides by 1500 in both of these examples. What you're going to get is you're going to get 2 different C2s. But what you need to do is add the 2 C2s together. So you have 0.5 times 600 divided by 1500. The first example there on the left side, you're going to get 0.2 molarities. On the next one right beside it is you're going to get 0.75 times 900, divided by 1500, you're going to get 0.45. And if you add these two together, 0.2 plus 0.45, you should get a resulting concentration of 0.650 molarity. That is the final concentration that is expected once this chemist mixes both these NaOHs, because they're the same compound. Our next thing we're talking about is what is solubility, and then what does solubility depend on. So what is solubility? Well, solubility is defined as, again, as the maximum amount of a solute which can dissolve in a given amount of solvent in a temperature. Its unit is grams per 100 milliliters or grams per liter. But it depends on many things. Number one, it could depend on what the solvent is. Because, for example, NaCl, when it dissolves in, for example, water, can dissolve 35.9 grams per milliliter. But when it's dissolved in ammonia, it can only dissolve 2.15 grams per 100 milliliters. So that should be 100 milliliters up there. And if it's dissolved in, for example, methanol, it can only dissolve 1.49 grams per 100 milliliters. It also depends on temperature, for example. Because if you talk about, for example, barium nitrate, if you're talking about it at 20 degrees Celsius, it can only dissolve 63 grams per 100 milliliters. If you're talking about it increased to 80 degrees Celsius, it now can dissolve 109.9 grams per 100 milliliters. So temperature can change how much can dissolve. So what does solubility depend on then? It really depends on 5 things. The 5 things it depends on is the type of solute. What kind of solute is it that you're dissolving? Number 2, amount of solute. Because if you have a lot of solute or a little bit of solute, that could change your solubility. Type of solvent. Amount of solvent. And last but not least, the temperature. These 5 things can change how soluble something is. As always, make sure you keep yourself safe and healthy, and I'll see you soon.